This video is going to talk about how to simplify expressions with negative exponents, because you can never leave an expression with a negative exponent. It's not fully simplified. In order to fully simplify those expressions, you have to make the negative exponent into a positive exponent, and that's what you're going to learn how to do and why you are allowed to do it in this video.
So we're going to look at how to simplify negative exponents. You need to simplify expressions that have negative exponents because an expression with a negative exponent, like an unreduced fraction, is not in simplest form. So it's important to understand that when you have a negative exponent and you're asked to simplify an expression, you have to make sure that you don't leave those negative exponents. So to simplify a negative exponent, an expression with a negative exponent, you're going to take the reciprocal of the base. So you're going to look to see what the base is. You're going to take the reciprocal of that base. So the reciprocal of 4 would be 1/4. And once you take the reciprocal, you are then allowed to change the negative exponent to a positive exponent. So 4 to the negative third will actually result in a decimal that's between 0 and 1. Because what you're doing is you're taking the reciprocal of 4, which is 1/4, and then you're taking 1/4 to the, or 4 to the third power, which would give you 64, and 1 divided by 64 is a decimal between 0 and 1. A number to a negative exponent will never result in a negative number unless the base is a negative number. So having a negative exponent on a positive base will result in a positive number always. It's a huge mistake that people make. So again, 5 to the negative 2, I'm going to take the reciprocal of 5, which is 1/5, and then I'm going to change the negative exponent to a positive 1. So 5 to the negative 2 is the same as 1 over 5 squared, which is the same as 1 over 25, which is the same as 0.04. Again, a decimal between 0 and 1. So a base that is greater than or equal to 1 that is taken to a negative exponent will always result in a number between 0 and 1. Please remember that. It'll never result in a negative number unless the base is negative. So it's important to kind of understand the why and the how. Like, why does this work? How does this work? So one of the ways that I like to show it is by showing two fractions. One has the smaller exponent on the top and the other has the smaller exponent on the bottom. These two fractions are not equal. I hope by looking at them you'd say, okay, that makes sense. They're definitely not equal. On the one on the left, the top number is way smaller than the bottom number because I'm taking 5 to the third versus 5 to the 7th. And then the second one, or the one on the right, the 5 to the 7th power is on top, so the bigger number is on top. So the one on the left is going to result in a decimal, and the one on the right is going to result in a very large whole number. When I go ahead and look at how this fraction looks with repeated multiplication, and I start playing let's cross out the things that equal 1 game, I have 3 things that equal 1, and I have nothing on top. Or it looks like I have nothing on top. In fact, I'm always going to have a 1 on the top because any number times 1 is itself. I just don't put the 1 there because there's no purpose to it. But in the end, there is a 1 on the top, and I'm left with 5 to the 4th, or 4 5s on the bottom. This should make sense to you because if I were to use those rules of division and common bases, my 5 is my common base, and I'm going to subtract 3 minus 7 and get negative 4. When I subtract 3 minus 7 and get negative 4, I'm left with a negative exponent, which I cannot leave because my expression will not be fully simplified. So according to the rule that we just learned, you're going to take the reciprocal of the base, which is 1/5, and you're going to change the negative exponent to a positive 1. Both of the ways that I just showed you result in the same answer. The repeated multiplication and crossing out your 1s shows you why you are able to take the reciprocal of the base and change the negative exponent to a positive 1. Positive exponent, not positive 1. The fraction on the right here shows you that if you were to go ahead and play the crossout game and cross out all the pairs that equal 1, you're left with 4 5s, but those 4 5s are in the numerator, and therefore it's 5 to the 4th over 1, not 1 over 5 to the 4th. So this is going to result in in a whole number, whereas the one on the left results in a decimal. So this is my favorite visual because it at least gives me some sort of understanding or clarity on why a negative exponent results in a fraction when the base is a whole number. So 4 to the third is 64, and 4 squared is 16, and 4 to the first, or 4, is 4, and anything to the 0 power is 1. Anything. So 5 to the 0 power is 1, 800 to the 0 power is 1. There are no 4s there. And as I said in the last slide, if there are no 4s, it doesn't mean there's nothing. It means there's an invisible 1. 4 to the negative 1 is 1/4. 4 to the negative 2 is 1 over 4 squared. And 4 to the negative 3 is 1 over 4 to the third. So I have 64, I have 16, I have 4, 1, 1/4, 1 over 16, 1 over 64. So the positive exponent and its negative counterpart will always be reciprocals of each other. So 64, which is 4 to the third, and 1 over 64, which is 4 to the negative third, are reciprocals of each other. So they're opposite exponents, 3 and negative 3, and their resulting answers are reciprocals of each other. As I go down 1 in exponent, so as I go from 4 to the third to 4 squared, or minus 1 from the exponent, what I am actually doing is dividing the resulting answer by the base. So 64 divided by 4 is 16. 16 divided by 4 is 4. 4 divided by 4 is 1. 1 divided by 4 is 1/4, etc. And this will work for every single number. As you go down 1 with the exponent, you are actually dividing the number by 4. So when you get into negative numbers, you are dividing 1 by 4. And then you're dividing 1/4 by 4. So you're becoming smaller and smaller as you go down. So the last two slides have showed you the hows and the whys, and hopefully given you a little bit of background and understanding as to why the rule of take the reciprocal of the base and change the negative exponent to a positive exponent works. And here are some examples of the math behind it, or the math using it. So 4x to the negative 6 is the same as saying 4 times x to the negative 6. The only thing that has the exponent attached to it is the x. So when I take the reciprocal of the base, the only thing that's the base is the x. And then I change the negative exponent to a positive exponent, and I get 4 times 1 over x to the 6th, which is the same as 4 over x to the 6th. So 4x to the negative 6th is the same as 4 over x to the 6th. When I look at 10x to the negative 2, it's the same as 10 times x to the negative 2, which is the same as 10 times 1 over x squared, which is the same as 10 over 1 times 1 over x squared, or 10 over x squared. When you look at 6x to the third in parentheses to the negative 4th, I now need to apply my exponent rules, and I'm taking a power to a power, so I take the reciprocal of the entire base, which is 6x to the third, and I change the negative exponent to a positive exponent. From here, I'm not done. I'm not fully simplified. I still have a parentheses in my expression. So I now apply the rule of distributing 6 to the 4th, x to the 12th. Since I don't really want to know what 6 to the 4th is, I can leave my answer as 1 over 6 to the 4th, x to the 12th. So again, the first thing I'm going to do is go ahead and apply my rules. And in this case, my rules say to multiply common bases. So when I do that, I multiply the coefficients. I keep the base the same, and I add the exponents. And 3 plus negative 10 is negative 7. And now I can't leave my answer as 12x to the negative 7 because x is to the negative 7. So this is the same as 12 times x to the negative 7. I make x to the negative 7 1 over x to the 7th. And I multiply 12 times that, and I get 12 over x to the 7th. For the last one, I'm going to use my rules of division. I'm going to divide my coefficients. I'm going to keep my base the same, and I'm going to subtract my exponents. 4 minus 9 gives me negative 5. I can't leave my answer. I have a negative exponent. I take the reciprocal of the base, change the negative to a positive exponent, and I leave my coefficient on the top because it doesn't have a negative exponent, and that's my final answer.